Saxon Advanced Mathematics, lesson 46. Some fun algebra today that will make you feel smart. Complex roots. All right, let me back up a little bit and just talk about roots. Let's say that I tell you that the roots of a problem are -7 and +4. And I want you to find the quadratic equation that they come from, right? I want you to write the quadratic equation whose roots are this. Okay, the way that we do that is we rewrite with binomials and we subtract whatever the actual root is, right? Which makes sense because we're working backwards, right? And we know that if we had this, this would give us x equals 4. So by saying x minus the root, we're setting up the binomials. We just have to be careful when we have a negative root because that will turn into a plus. And now we can multiply this in our head. Let's see, it'll be, well, let's just do it. X plus 7, and I don't need the parentheses, x minus 4, it'll be x squared plus 7x minus 4x minus 28. So then we can say that the quadratic equation with a lead coefficient of 1, which is what we say because obviously we could multiply these three terms by any number we wanted and it would still be true. So when John says a lead coefficient of 1, he means like just don't trick this up. Just leave it as simple as you can. That's how we do this, right? Okay, this is familiar. We've done it before. What we're going to do in this problem is do this very thing, except our roots are going to be complex numbers. And remember that a complex number is a plus bi, where this is the real part and this is the imaginary part. And we always respect this beautiful relationship. Okay, right? Make sure you have that. I want to make sure that's burned, engraved. Let's not say burned. It's such a violent image. Engraving is kind of rough too, though, isn't it? Okay, so example 46.1. That wasn't an example. That was just to remind you of how this works. Okay, write the quadratic equation with a lead coefficient of 1 whose roots are, so we can write x equals 1 plus 2i and 1 minus 2i. Okay, there's the complex numbers I warned you about. So we remember that what we do is we make it x minus, and then we'll put this in parentheses, 1 plus 2i. And then the other quantity will be x minus that one, 1 minus 2i, and that will equal 0. All right, this is the exact same procedure we did for last time. We just have a nastier chunk. Last time we had, what, -7 and +4? But we just plunk them in and put minus signs in front of them. Now we have to distribute these. So this will be x minus 1 minus 2i times x minus 1 plus 2i equals 0. Look good? We're following the exact same procedure that we did for the simpler version that I reminded you of just a hot minute ago. Now we're just seeing, it's a little messier, but it's more or less the same. Now we have to multiply these together, just like we did last time. We'll stack them and do the dance. And we'll see what cancels out. Okay, remember the dance is that these are the boys and these are the girls and they're in the studio and it's Saturday morning and their parents are making them take dancing lessons and the teacher tells them who to dance with because everyone is really weirded out by this whole dancing thing. They're like 10, 11 years old. So the teacher says, okay, the first girl dances with all three boys. X with x. That's x squared. X times minus 1. X times minus 2i. And this becomes a bit of a mess to write. I like to put the number first, then the x, and then the I. All right? The order doesn't matter. That's the way it makes sense to me. She's done. She sits down. Now it's her turn. minus x plus 1. That's a plain number. I'm going to put that down here because it needs its own category. Plus 1, and then this will be plus 2i, and that needs its own category too, doesn't it? All right, she's done. Now it's her turn. Now she is plus 2xi, right? 2i times x minus 2i, so I'm lining them up underneath. And then this, wow, this is going to be a thing, right? So these two together, it's my last multiplication. It's going to be a minus 4i squared. But remember that I squared equals minus 1. So this is going to turn this into a plus. So I'm going to write plus 4 right there. Now let's see what to make of all of this. We have x squared minus 2x. These cancel, plus 5 equals 0. That is the original quadratic equation that yielded these roots. We did it. We worked backwards and found it. The concept we have already practiced. What's happening now is we're just having to drag these complex numbers into it. This is called, no, this is not. This is called finding the quadratic with complex roots. Now we're going to go back to working in the other direction. If you think of this as backwards, where we're working from the answer back to the original problem, we're going to go here and practice going in that direction. Okay? So the same operation, we're learning it from back to front and front to back. Example 46.2. And let's see how many problems we have. We have this one and one more. Okay, so this problem says factor 2x squared plus 4x plus 8 over the set of complex numbers. Okay, that's just a fancy way of saying solve this. All right, so the first thing that we can do is set this equal to 0. That's kind of nice. Then we see that there's a factor, these are all divisible by 2. So let's look at, instead of dividing, let's factor out 2 from everybody. So we'll have x squared plus 4x, oh, I'm sorry, plus 2x plus 4 equals 0. Okay, I just factored the 2 out. Now, we know that when we finish factoring this, we're going to have 2 binomials, and then we'll say one of these 3 things has to equal 0. 2 equals 0 is not going to be part of our solution, is it? So we can say right here, I'll write it over here, 2 equals not 0. That's not going to be part of our solution. So we can just drop that, and we'll change this to be x squared plus 2x plus 4 equals 0. All right? So we factor out and eliminate any numeric values that are pumping up our values, if you will, right? And we can eliminate it because we know we're going to factor it out, and then we would say, oh, is that number equal to 0? No, it's not. That's crazy. All right, now we have a nice clean equation here, and we're going to use the man-eater to solve it. Remember that the man-eating dragon always works. If we can solve it by inspection, yay, it saves us time and a little bit of stress, but a lot of times we can't. And because this problem tells us that we're factoring over the complex numbers, that's just our hint that the answer is going to be a complex number. So we can't see those by inspection. So let's just grin our teeth and do it. 1, 2, 4. Please make sure that the quadratic formula is burned deep in your mind. Memorize it always by leading with an x. Right? Always, when you're using the quadratic and plugging your values in, always use buckets. Unless you like to make doinky mistakes and redo your work for no good reason. I don't. I always use buckets because I don't want to make doinky mistakes. All right, there we are. A is 1, B is 2, C is 4. Before I regroup, I always do this part first. 2 squared is 4 minus 16. Oh, there's my complex number, right? This is where this is my discriminant. Remember we learned that in Algebra 2? The value of this thing inside the square root tells you whether you're gonna have 2 real number solutions. That's if this number is positive. 1 solution, that's if the number is 0. And 2 complex number solutions if this is negative. So we got negative. So that's okay. We knew we were gonna get complex numbers. X equals minus 2 plus or minus the square root of 12i. That can be simplified, but I'll get to that later, over 2. Okay, this is looking really good, isn't it? We're doing very well. This was negative 12. When I take the square root, I bring the minus sign out. Remember that the square root of negative 1 equals I. So when I created that negative 12 in here, I brought the negative out as the negative 1 out as an I. Now I'm just going to factor the 12, which I can factor just like always. It's going to be 2 times 2 times 3. There's a pair of 2's. I can bring 1 out, and that will leave me with a square root of 3 inside. So I'm going to have x equals minus 2 plus or minus 2 times the square root of 3i all over 2. Now, what I'm actually doing is I am factoring out the 2 and then canceling it against here. The best way to show that is I'll factor the 2 out of the top. That'll leave me a minus 1 plus or minus square root of 3i over 2. Now I can cancel there. Does that make sense? All right? Some students just want to cancel right here. If we're careful, we can, but the best way to do it is to factor first. Sometimes we kind of factor in our heads and then cancel, but I really want you to be careful and factor that 2 out and then cancel. Remember, we can cancel when we're multiplying, but not when we're adding and subtracting. That's why you don't really want to cancel here. You want to factor first. Okay, I'm going to copy this over to the next page. I've got x equals minus 1 plus or minus square root of 3i. Okay. Now that we've got the roots of this, we want to go back and write this as the 2 binomial factors. So the way that we do that, just like we were doing before, is we'll have x minus one version of this, and x minus the other version of this, minus 1 minus square root of 3i, equals 0. We distribute this. So this will be x plus 1 minus square root of 3i and x plus 1 plus square root of 3i. This all equals 0. And now, just to put the absolute cherry on the ice cream sundae, remember that 2 that we eliminated back before? We'll bring it back, right? We factored it out and ignored it and just went on with the rest. Now we're bringing it back right here and letting it back into the equation since it was originally there. this is our final answer. All right, and it shows not the original quadratic. Let me show you. This was the original equation in quadratic form. Then we factored it and we found the roots, and then we went back and wrote the binomials that created kind of the halfway point, right? Because we didn't factor by inspection, we never saw this form of it. Our quadratic equation took us right to the answers, so to speak. These are the roots. But then we were able to take those roots, because we're smart little puppy dogs, and recreate what that quadratic equation would have looked like if we would have factored it by inspection. So that's what we have here. It's fairly exhausting, isn't it? That's a lot of steps. It's a lot of steps. But what we're doing is we're creating that kind of halfway point that we didn't get before because we used the man-eating dragon to solve it. Okay, we have one more of these. Why you would want to do this, ours is not to question why. We're just doing it. 46.3. I just want you to see that we're going from, what am I doing here? We're going from the quadratic equation to the roots and then back to the binomials, right? It's kind of a weird order. Okay, x squared plus 2x minus 5. And again, we're told to factor this. John doesn't say this time factor it over the complex numbers, but that's what this is called, which is a really long, complicated thing. And it'll always have that basic form, right? Okay, so we're gonna go from the quadratic equation, or the quadratic equation, let's make it an equation. We're gonna go from here to the roots. And then we're gonna go back and recreate the binomials. Again, why? I don't know. Let's just do it. Okay, so this time we don't have to fool around with canceling anything out. We can go straight into our man-eating dragon process. This is all clean and pretty, so we'll say, I'm gonna write it over here, A equals 1, B equals 2, C equals minus 5. We'll fire up the man-eating dragon. We'll create parentheses. All right. Sorry, I go really fast on these. I'll slow down and give you a chance to breathe. You can always pause me, you know that, right? Of course you do. All right, now let's plug in our values. A, B, and C. Okay, so far so good. Let's simplify in here first. This is gonna be 4 plus 20. Okay. Well, it doesn't sound like we're going to have an imaginary number here, but that's okay. We can still do it. So this is going to become x equals minus 2 plus or minus the square root of 24 over 2. Now, we can break this out. This is 24. I know it's 2 times 2 times 6. 6 we could break down further, but I can see, oh, there's my pair that's going to come out. So this is going to be 2 square root of 6. But now I can also see that I'm going to have to factor out the 2's again like last time. So I'm going to do this all in one fell swoop. I'm going to factor out the 2. This first one is minus 2. Then the 2 that I bring out here is factored out. So I'm left with plus or minus square root of 6. Oh, I'm sorry, this is a 1 because it was a 2 and I factored out the 2. So I've got a 1 as a placeholder. That makes sense? I factored out the 2, so that's the minus 1. I factored out this 2, so that's why there's nothing in front here, even though I pulled out a pair of 2 pigs. And what's left inside the pig house is a 6, square root of 6. And then on the bottom, I've got that. So my final answer is x equals, now these cancel, and it's minus 1 plus or minus the square root of 6. Now, I'm going to squeeze here. So now I've got x minus 1 plus the square root of 6. I'm going backwards to get my roots, right? X minus 1 minus square root of 6 equals 0. So now all I have to do is distribute my minus sign. X plus 1 minus square root of 6. X plus 1 plus square root of 6 equals 0. There's my quadratic equation written in binomial form. Guess what? It's right. So here's my quadratic equation. Here is my root. And here are my binomials. Wasn't that fun? Don't you feel smart? You can look at this big old hairy mess and go, oh yeah, that wasn't too bad. Yay. Yay. We're done with lesson 46. Lesson 47. We're coming back to the sinusoids. All right, so we're going to talk a little bit more about our periodic functions. I want to tell you that, well, no, I'll save that story for tomorrow, but I have a story about periodic functions and how they popped into my daily life. 46 is over. Thank you. Goodbye.